Hello, ladies and gentlemen. Ms. Rector back here, going to talk to you today about scientific notation. Hopefully, you have seen this somewhere before, and we're just doing a review. If not, feel free to pause things if you need to. I'll tell you what, I'm going to turn on the pointer here so it's easier for me. I'll try turn it on closed captions. Maybe that'll help some of you understand if you can see what I'm saying. Take that out of the screen. Okay, so scientific notation is a way to write really big numbers or really, really small numbers in a condensed form. Um, so we try to make it more concise. So there's a couple of parts to a number in scientific notation. By the way, if you do not have your scientific calculator out, go ahead and pause this and get yourself a scientific calculator. You're going to need that here in a moment. So the number, you want to make a number between 1 and 10. That is what's going to go here. So this number should be bigger than 1 and less than 10. You're going to move the decimal to make this number bigger than 1 and less than 10. And then you're going to have some power of 10. So times 10 to some power. That scientific notation number will look like this. So what are the rules? So the first rule, and again, feel free to pause this and write these in your notes. First rule is to place the decimal point so there is one non-zero digit to the left of the decimal point. Again, think of it as you're making a number that's bigger than 1 but less than 10. Now, when you move that decimal, you're going to have to move it a certain number of places. So count the number of decimal places that you move it. That is going to be your exponent of 10. So that's going to be the power you put over the 10. Now, if the original number was a really small number, was less than 1, then the exponent is going to be negative. If the original number was greater than 1, then you're going to have a positive exponent. So let's see some examples. This number, this is the expanded form here. Now, we've already mentioned significant figures a little, so these zeros are not significant. They're not measured numbers. They're just placeholders. So we could write this number in a more concise way. So the first rule was, where can I put a decimal that'll make it bigger than 1 and less than 10? Well, if I put the decimal right here, I would have 2.898. That's bigger than 1, less than 10. I am able to drop these zeros because they are not significant numbers. They are not measured numbers. They're only placeholders. I have to keep these digits because they are measured significant digits. So I can't just get rid of them. They have to be part of my number. So I have 2.898, and I moved the decimal. There was, of course, no decimal written there, but it's implied that it's right there. To move it, I moved it 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So that gives me my exponent is 8. That's because I moved the decimal 8 places. So my answer, 2.898 times 10 to the 8th power. There's my new concise way to write this number. Now, because this number was greater than 1, this is a positive exponent. So down here we have an example of a number that is less than 1. Again, these zeros, according to our significant figure rules, are just placeholders. They're just putting the 5 and the 6 in the right column, right? So this would be the tens place, the hundreds place, thousands place, etc. So these are just placeholders. We can drop them when we use scientific notation. So I want to move the decimal to where I can get a number that's bigger than 1 but less than 10, which would be right here. So 5.67. To do that, I had to move it 1, 2, 3, 4 places. And because this number is less than 1, the original number is less than 1, I have a negative exponent, so the negative 4. So 5.67 times 10 to the negative fourth. If you're doing the opposite, if I give you something in scientific notation and you want to put it in standard form, again, you're just going to move the decimal. But remember, if you have a positive exponent, the number you should get will be bigger than 1. So you're going to want to move the decimal to make the number bigger than 1. If you have a negative exponent, you're going to move the decimal so you get a number smaller than 1. So you move it to the left to get a number smaller than 1. And then just fill in your zeros. So for example, if I've been given this number, I say, okay, this is a positive exponent. I'm going to make a number that's bigger than 1. So I'm going to move the decimal 6 places this direction. 1, 2, 3, 4, 5, 6. So I got 1, 2, 3, and then 4, 5, 6. I had to fill in some zeros there. In this one, the exponent is negative, so the original number must be less than 1. So I'm going to move the decimal to the left to make that happen. I'm going to move it 4 places to the left. So you can see I moved it 1, 2, 3, 4 places to the left. Okay, I would like you to take a second, pause this video, try to write these numbers in scientific notation on a piece of paper or something. Just give it a shot, and then I'll show you the answers here in a second. So go ahead and pause the video and then try. Hopefully, these are the answers that you got. So again, here, notice all the numbers here are significant figures. I can't get rid of any of them. I can't drop them, but I can put it in scientific notation. I want to move the decimal here so I get a number that's bigger than 1 and less than 10. To get there, I had to move the decimal 1, 2, 3, 4, 5 places. So 10 to the 5th power. The original number was greater than 1, so positive exponent. Here, I moved it over between the 3 and the 8 for 3.872, negative 3rd power because this number is less than 1. Now here, none of these zeros are significant, so I could get rid of all of them. I don't even really need to have like a 0.0 because this is just no significant numbers of these zeros. So 3 times 10 to the 9th power. And this one, you might say, well, how do I do that? That's silly. Why would I write this if I could just write this? And you're right. We're not going to do this very much unless you're doing, you need it to do the math, which if you have a scientific calculator is no problem. If you don't have a scientific calculator, sometimes you'll find you'll need to write numbers like this so you can multiply or divide them with scientific notation numbers. Anyway, we use 10 to the 0 power because 10 to the 0 power is equal to 1. We didn't move the decimal anywhere, so 2 times 1 is 2. Here we go, this one. Again, you can't really drop many zeros except for this one. This 0 you have to keep because that is a measured significant figure, right? So you're going to move the decimal just 1 place. So you get 4.78260 times 10 to the negative 1. Now, let's talk about your calculator. So get your calculators in front of you, and I want you to locate the button that your calculator has to do scientific notation. It might be 2 capital E's, it could be an EXP, a times 10 to the N, or times 10 to the X. There's a lot of different styles of calculators out there. So we're going to try typing this number right here into your calculator. So find this button, whatever it is in your calculator. You're going to use that button instead of typing the times or the 10. So to put this number in, you're going to type 4.05. Then you're going to hit EE or EXP or your times 10 to the X button. And then you're just going to type in the power or whatever the exponent is, so 25. When you hit enter, your calculator should have something like this. Now, different calculators do it differently. Some of them don't put times 10, they put an E or some shorter way of writing it. So you need to know how your calculator works. So give that a shot. Pause if you need to, try it. And then we're going to try doing some math problems. Some calculators are pickier than others. So I'd like you to try to put this into your calculator. Some of you, if you have calculators, may not need parentheses around things. For example, my calculator, I can just type in 5.03. Then I have like a times 10 to the x button I can hit. So I just type that button, then 24. Then I can just hit divide and start typing this number in. If you do that and you get some other answer, like if you get this times 10 to the 27th or something, it's wrong. Your calculator needs parentheses and to do the math. So give this a shot. Try typing this into your calculator. See if you get this answer. Now, your calculator might give you 8.355, blah, 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 blah. There's definitely more to this number, but I rounded it according to the rules for significant figures. So if this number has 3 significant figures and this number has 3 significant figures, my answer can only have 3 significant figures when we're multiplying or dividing. All right, that is today's lesson. Good luck.